David Ogilvy once said that the big ideas are usually simple ideas.
Welcome to the A&P Professor. A few minutes to focus on teaching human anatomy and physiology with host Kevin Patton.
In today's episode, I discuss cholesterol, oxytocin, stress, and the big ideas of A&P. I think all of us discuss cholesterol in our courses and its various roles in the human body as a precursor to some of the hormones, the steroid hormones, and as a component of cellular membranes. And we probably also mention the fact that there are cholesterol particles that are floating around in our blood, and they are in the form of these little balls that form by way of a protein called an apolipoprotein. Apolipoprotein B, or just ApoB for short, is sort of the organizing molecule for these lipoprotein particles, including the low-density lipoproteins, LDLs, or non-high-density lipoproteins, that is non-HDL, cholesterol particles. And we know that the more of these lower-density particles we have floating around in our blood, the higher our risk for cardiovascular disease is. So that's something that we know well, and I'm glad we do, because I've inherited that characteristic of having high LDL levels in my blood. And so I've taken steps to reduce that because, heck, I already have enough cardiovascular risk, a history of heart disease in my family. I'm a male over a certain age. I'm an A&P professor, therefore I have a high-stress job. I have all kinds of, then again, I'm a podcaster, and that helps me work my stress out by telling all of you about it. You're my therapy. So that reduces my cardiovascular risk a little bit, I'm hoping, and so does exercise, and so does taking statins, which I do. So there are a number of things we can counteract that with. But you know that the monitoring of cholesterol levels is a very important part of primary medical care in our society. And it turns out that the various bodies that make recommendations about, how and why we should be doing that are in the process of revisiting those guidelines in light of current information to see whether any changes are needed. And we won't see that for a few more years, but they're working on it. And not just in the United States, but in other areas of the world as well, like Europe, for example. And when those recommendations come out, there's a possibility that we're going to be seeing a shift in how we do screening and how we do health monitoring for these cardiovascular risks related to the buildup of plaques in our blood vessels. And there might be a shift away from focusing on LDL levels or non-HDL cholesterol levels and looking instead or in addition at the ApoB levels. Because we're thinking, based on current evidence, that the rise and fall of ApoB in our bloodstream is giving us a more direct measurement of the number of particles that there are floating around in our blood. And those particles could be really big or really small. And, the total amount of LDL is what's being measured, but that's not telling us the number of particles. Maybe the ApoB is a better measure of how many particles. And there are a number of cardiologists and researchers who are really pushing for ApoB, which is a very inexpensive blood test, an ApoB blood test to be the primary way that we assess cardiovascular risk in this regard, instead of the LDL ones. Now, I'm thinking, not being an expert in this at all, but My uninformed opinion, or relatively uninformed opinion, is that we're going to see some shift, but not a replacement. That we're going to start to see ApoB tests being given more routinely and used in conjunction with LDL tests. But there are some cardiologists who feel like we don't need the LDL test. The ApoB test tells us all we need to know. So just a little heads up, and maybe we can start having a little bit of conversation when we're talking about those cholesterol particles in our blood and mention the ApoB and maybe emphasize it a little more than we have before, because it might be a major player in the stories we tell about how cardiovascular disease works in the human body. We know that at the end of pregnancy, in the ideal situation, oxytocin levels increase, and that has the effect of increasing the smooth muscle contractions in the uterus, in those myometrial smooth muscle fibers. And that's going to enhance the whole process of labor and delivery. So that we've known for a long, long time. But what we have not known and still are kind of working out is, how does oxytocin do that? And not long ago, the Journal of Physiology had a paper that does a good job of explaining most of it, maybe even all of what's going on, by identifying a kind of potassium channel that had previously not been identified in uterine smooth muscle. It's called SLO2.1, if you want to know, but we'll just call it that potassium channel. And what they found was that oxytocin inhibits that potassium channel. So it's going to inhibit the leaking of potassium out of the cell. And when it does that, it's going to cause a depolarization of the membrane of those uterine smooth muscle cells. And when the smooth muscle membrane depolarizes, it's going to eventually open up some of those voltage-gated calcium channels that we know are there in all muscle cell membranes. And when the calcium flows in, because those voltage-gated calcium channels have now been triggered, then that's going to contribute to uterine contraction. So here's something we didn't know before. And what's interesting about this for me is that it brings to play something that our students have already been talking about, right? I mean, they've already been talking about the role of the action potential in muscle contraction back when they were talking about skeletal muscle contraction. And they know the role of depolarizing the membrane in triggering those voltage-gated calcium channels, so the calcium will rush in and get the whole process of muscle contraction going. So that the students already run across that part when they were talking about muscles. They also went into some deep detail about how potassium affects membrane potential and how opening and closing ion channels in a membrane affect action potential or membrane potential in general, but certainly create an action potential and change resting membrane potential. And they did all that probably, or most of that, when they were discussing the neuron and how neurons work. So here's elements of stories that have come up more than once before, and now here it is again in a different context, the context of explaining how oxytocin works. Now, I'm not sure I'm necessarily going to go into all of this when I talk about oxytocin in my course. I mean, they already are pretty overwhelmed with what I'm having them learn to begin with, but it's going to inform my story. It's going to give me a little bit more background as a storyteller, and there might be some opportunities, especially when students ask questions about the hows and the whys, and often there are those kind of questions, right? And we'll have that there and say, well, an emerging idea is, here's how oxytocin might help with that, how it might work. This podcast is sponsored by HAPS, the Human Anatomy and Physiology Society, promoting excellence in the teaching of human anatomy and physiology for over 30 years. go visit HAPS at theapprofessor.org/HAPS. Stress. That's a topic that we A&P teachers are interested in, right? Because the topic of physiological stress comes up a lot in the A&P course. And not only that, the phenomenon of experiencing stress, that comes up in our course too, not only in our students, but in ourselves as well. So I was interested when I ran across some information that came out in a journal article from some researchers from the University of British Columbia, and they found that smelling a romantic partner's clothing was associated with lower levels of the stress hormone cortisol in women's blood. And so, in a nutshell, what they did was they took almost 100 couples, and they were opposite sex couples. So they took the male partner and had them wear a new t-shirt, previously unworn t-shirt, for 24 hours without using deodorant or scented products or eating food that caused a change in their body odor, and no smoking, anything that would affect the smell. And then after that was done, they took the female partners and put them into a somewhat stressful situation. I think it was a mock job interview or something like that. And so there was a certain level of stress that was recorded in most of those women because their cortisol levels went up. So they did that with the women were just wearing a fresh t-shirt, and yep, a lot of these women had a certain moderate level of stress, or at least of increased cortisol levels. Then they tried it with having the women wear the t-shirt from their romantic partner that definitely had the smell of that person on them, on the shirt. And when they did that, they found the cortisol levels were lower. So they're thinking, well, the smell of the romantic partner, the smell of a loved one, is going to reduce or in some way modulate that stress response, at least as indicated by the changing levels of cortisol. And they did another part of the experiment that was interesting as well. They had women wear a shirt from a man who was not their romantic partner, a strange man. And so they found that in those cases, the women's cortisol levels went even higher than it would have otherwise. So they had sort of a baseline level of stress without any smells. And their stress level went down when they could smell the romantic partner, and it went up when they could smell a male who was not their romantic partner. So that tells us a little bit more than we knew before about stress and about the relationship of different smells to stress. And I think that we're going to find that that extends to other kinds of smells as well. Maybe our stress is reduced when we smell a pet or one of our children, the smell of one of our children, or ice cream. I think that would do it for me. I know eating ice cream, well, I don't know if it reduces my stress, but I feel like it must, so I do it. And maybe the smell of ice cream will be enough to lower stress. And so I know the smell of a circus lot reduces stress, the smell of a zoo, which a lot of people don't like. To me, that is stress reducing. So maybe there are even quirky smells that are individualized to us as individuals. And maybe this has some practical applications. Maybe, wasn't that long ago when I was discussing test anxiety on this podcast. And so maybe we should recommend that our students, when it's exam day, that they wear a piece of clothing that had been worn by a loved one. And maybe that'll help reduce their stress, reduce their test anxiety. I don't know. Somebody out there do a study and let's see if that works. A searchable transcript and a captioned audiogram of this episode are funded by AAA, the American Association of Anatomists, at anatomy.org. As I mentioned in episode 12, in which I focus on storytelling as a teaching strategy, I often tell my students that I'm telling them stories about the structure and function of the body as I discuss A&P concepts. And when I'm storytelling, I often ask them to try and distill from the stories what I sometimes call the big ideas of human biology. When we come across those big ideas again in later stories, those told later in the course, and we always do come across those big ideas again, I once again point them out. I want students to get in the habit of looking for those big ideas. I want them to understand that it's these big ideas that provide the framework for understanding the whole arc of the story of human biology. I want my students to gain skills in identifying the underlying themes of the series of stories that make up our current understanding of human biology. I want them to be able to pick out the major characters and the minor characters in the story. When we tell a story in A&P, aren't we really wanting them to understand the characters deeply? What structures are involved? Which molecules are involved? Why do they act the way they do? What's their motivation? Isn't that how students understand mechanisms? This structure has a certain shape, and that shape determines whether they can do this or that. This solution has a certain concentration of this or that substance, which determines what will happen next. This membrane has certain receptors or channels or carriers that determine what will happen or what cannot happen here at this location in the body. Or another character, this molecule, it has a positive charge, and that one has a negative charge. And that will tell us how they'll interact. Oh, look, these two molecules both have the same positive charge. How are they going to interact? When we start thinking this way, when our students start thinking this way, that it's all a bunch of characters that are interacting in certain ways and have certain motivations, certain mechanisms that they exhibit, then all of these complex structures and processes of human biology come alive in a way that just doesn't happen in a simple listing or description of them that we typically see or hear in a science course. These structures and processes now have a meaning that they didn't have before. Of course, before we can start getting our students to gain skills in identifying the big ideas so that they can really focus on them and work on understanding them, we need to be able to do that. If this is new for us, a new way of looking at these stories we know so well, how do we ourselves gain those skills of finding the big ideas? I think just looking at it from that fresh perspective we have when we first realize that there are indeed a set of big ideas to be found, then that alone may be enough to get us on the road to gaining the needed skills. Another way is to look at the big ideas that have been identified by our colleagues. Such examples can jumpstart our thinking and help push us along in developing our own insights, I think. A place where I recommend starting with that is a book called The Core Concepts of Physiology, A New Paradigm for Teaching Physiology. It's put together by Joel Michael, William Cliff, Jenny McFarlane, and Harold Modell, and Ann Wright. And it's published on behalf of the APS, that is the American Physiological Society, and produced by the publisher Springer. I mentioned this book in the preview to this episode, and I'll have the links not only in the preview, but in the show notes and episode page for this episode. So in this book, which I'll just use the main part of the title, The Core Concepts of Physiology, they identify, through a process described very carefully in the book itself, they identify 15 core concepts of physiology. So among them are things like, well, I'll just read them off real fast. There's only 15 of them, and I have them listed here, so might as well. First one is evolution. Second one is homeostasis. Third one is causality. Next one is energy. Then structure and function. Then the next one is cell theory. Then the next one is levels of organization. The next one is cell-cell communication. Then cell membrane. Then flow down gradients. Genes to proteins. Interdependence. Mass balance. Physics and chemistry. And lastly, scientific reasoning. Okay, so that gives you an idea of some of the big ideas of physiology. And of course, there are similar big ideas in anatomy. But let's take an example. One that popped out to me the first time I saw this list is flow down gradients. And I thought to myself, wow, the flow of something down a gradient comes up in all kinds of stories we tell, doesn't it? For example, the flow of particles down a concentration gradient, the flow of ions down an electrical gradient, the flow of air down a pressure gradient in the respiratory airways, or the flow of blood down a pressure gradient in the circulatory system, or the flow of lymph in the lymphatic system, or urine in the urinary tract. Okay, that's enough examples, but you can see where this idea of a flow down a gradient is a really important, a really big idea in understanding human structure and function. And it's a pretty simple idea, I think. Once you get it, once you identify that as the idea behind all of these different examples, then those examples become far less complex because students can immediately recognize that simple idea that is behind what at first glance might seem like a complex process. Now, the list in the book, The Core Concepts of Physiology, gives us some big ideas. But I think each of them has other big, or maybe not quite so big, ideas built into them. And I'm on a quest. I'm on a quest to identify all of those smaller ideas that are embedded within these big ideas. That is, the kind of big ideas. Yeah, I'll call them that, the kind of big ideas. Because those are the ones that I'm really focusing on in my course. That's a quest that I think will never be over. But I'm okay with that. Heck, I'm kind of glad it'll never be over because it's so much fun looking for all of them. I don't want my quest to end, really. But I do want to still continue to find more and more of these core concepts, these big ideas that are embedded in the story of human biology. Now, this may remind you of something that I discussed in a previous episode. In episode 8, I brought up the idea of running concept lists. And what that is where I encourage my students as a practice in their study of anatomy and physiology to keep a running list for each of these big ideas or each of these recurring concepts, if you want to call them that. And they keep that list, they run that list, like in the back of their notebook or in a separate notebook. So at the top of one page, they might have something like gradients or flow down gradients. And then every time it comes up throughout AMP1 and AMP2, they, once they get in the habit of this, they go to their running concept list and say, oh, I have a concept list for flow down gradients. So they add it to it. So when they get to, the flow of blood down a pressure gradient in the circulatory system, they can say, aha, another gradient. I'll add it to my gradient list. And then when you get to lymph and you talk about the pressure gradients there and how and why lymph flows the way it flows and what direction it flows in, you can say, aha, there's the gradient again. And they can put it on their gradient list. And so it's sort of a continuous process of running all these lists. And every time they come across a new big idea, then maybe it'll be the second or third time they've seen it. And so then they realize, aha, that's a big idea. I need to make a concept list for that. Or I might tell them in class, hey, this is a big idea. You might want to start a concept list on this because this is something we're going to be seeing time and time again. And of course, when we get across those or come across those big ideas, I'm going to point them out when I can. I'm going to say, look, here's a gradient again. Here's another example of how knowing about gradients and how they work is going to help us understand a process in the human body. So that's the sort of big idea of big ideas. That is, the big idea for today of this whole segment is, let's start looking at the big ideas. Let's start emphasizing those as we tell the story of human anatomy and physiology. I think it'll help our students build a conceptual framework where they can take new information that they get as it comes along and put it someplace where it makes sense inside their mind, because they're building this conceptual framework. And we're helping them do this by pointing out examples of big ideas that they need to grab a hold of and put somewhere in their head, or at least in their notebook at first, and then it'll get in their head. So that's the big idea for today. Hey, I'd love to get your feedback on these big ideas. What are some more of them? What are some big ideas that are especially important in anatomy? Like maybe the role of fibers in giving strength to tissues, or the bigger idea of how the extracellular matrix of a tissue imparts specific characteristics to each type of tissue, or the even bigger idea of how different tissues have different roles in the structure of an organ, or what constitutes an organ. Okay, this riff could go on all day, but let's hear from you about some more of the big ideas of anatomy and physiology, or anything else you want to talk about. Just call the podcast hotline at 1-833-LION-DEN. That's 1-833-546-6336. Or email me at podcast@theapprofessor.org. Or reach me on Twitter at @theapprofessor. Talk to you next time.
The A&P Professor is hosted by Kevin Patton, professor, blogger, and textbook author in human anatomy and physiology.
Some of the places, names, and events used in this episode are fictitious or are used fictitiously. Any resemblance to actual persons, living or dead, or actual events is purely coincidental.